Hi guys, and welcome to another video. In this video lesson, we are going to be looking at grade 11 maths, exponents and surds. And we're going to be looking at how to simplify expressions using the laws of exponents from past year exam questions. And this is part 3 of a series of videos. The question that we're going to be looking at now is from the November 2013 paper 1, and it reads as follows: given 4 to the x minus 1 plus 4 to the x plus 1 all over 17 times 12 to the x. Simplify the expression fully. So for 2.2.1, to simplify this particular expression, in our numerator we got 4 to the x minus 1 plus 4 to the x plus 1. Remember that there's two terms in our numerator. So in order for us to factorize it, we have to write as separate terms. And that's very important for us to do. So therefore, 4 to the x minus 1 can be written as 4 to the x times 4 to the minus 1. And here we have plus 4 to the x times 4 to the positive 1. Then here in the bottom, we have 17 times 12 can be written as 3 times 4 or 3 times 2 squared. But I'm going to write it as 3 times 4 to the power x. The reason I'm going to do that is because I have 4 to the x here, which I know I'm going to remove as a common factor. Then I'm going to have 4 to the x here, so I can actually cancel the 4 to the x's off. So therefore, 4 to the x now can be removed as a common factor, which leaves me with 4 to the minus 1 plus 4 all over 17 times 3 to the x times 4 to the x. So as you can see, 4 to the x and 4 to the x now will cancel, which leaves me with the following: 4 to the minus 1 plus 4 all over 17. So we say 1 over 4 plus, that's 4 over 1, all over 17 times 3 to the x, which will now leave me with the following: 1 over 4 plus 4 over 1 can be expressed as 16 over 4, getting a common denominator there, all over 17 times 3 to the x. So let's see what we have over here now. We got 16 plus 1, there is 17 over 4, all over 17 times 3 to the x, which will equals to 17 over 4 times 17 times 3 to the x over 1 will be 1 over 17 times 3 to the x. 17 and 17 cancels, which leaves me with 1 over 4 times 3 to the x. Now in the next question, it says here that if 3 to the minus x equals to 40, express 4 to the x minus 1 plus 4 to the x plus 1 all over 17 times 12 to the x, which is that expression. Let's express it in terms of t. We got here equals 2. So if you take 3 to the x to the top, it's 3 to the minus x all over 4. And what do they tell us here? 3 to the minus x is 40. So therefore what you'll write down, you can now write down 40, which is going to equals to 4 t over 4, which is equal to 4, and 4 cancels, which leaves me with t. Alright, now let's look at another question here, which is from the November 2015 paper 1. Okay, and then the first question that we have here on exponents is 2.1.1, which is 2 to the n plus 2. So 2.1 to the n plus 2 times 4, you can write it as 2 squared to the n plus 1 all over 2 cubed to the n minus 1, which equals to 2 n plus 2 times 2 to the 2n plus 2 all over 2 to the 3n minus 3, which will leave me with 2. So yeah, I've got n plus 2, n plus 2, plus 2n plus 2, plus 2n plus 2, minus 3n plus 3 because you have to change the signs. So let's see what we got here. N plus 2n minus 3n cancels. 2 plus 2 is 4, and 4 plus 3 is 7. So 2 to the 7, which is 128. Okay, let's look at the next question there. 2.1.2. So I'm only going to do the questions on exponents and surds, right? So I'm not going to do this one here. So 2.1.2. Here we got the square root of x plus the square root of 2 minus x into the square root of x minus the square root of 2x minus 1. So here, if you look at it very carefully, what do you notice? You're going to have the square root of, so you can multiply here, that's sum and difference. So that'll be x times x is x squared, plus times minus is minus into 2x minus 1, which leaves me with the following: the square root of x squared minus 2x plus 1. Now let's look at this. X squared minus 2x plus 1 is, if I have to factorize that, it's going to be x minus 1 all squared. Why? If you square the first term here, you'll get x squared. If you double the product, you get minus 2x, and if you square the last term, you'll get plus 1. So therefore, the square root of x minus 1 all squared will be x minus 1. That's my answer, x minus 1. I'm going to look at this question here now, which is 2.3. Calculate the sum of the digits here. 2 to the 2015 times 5 to the 2019. Let's have a look at that question. So what we want to do here is we want to now write both of these bases to the same index. The reason we want to do that is we're going to use this rule here. X times y to the n is equal to x to the n times y to the n. Okay, so what does that tell us? It tells us that if we have different bases but the same index, then we can multiply the bases. So let's take a look at that. So for 2.3, let's write that down. So we got 2 to the 2015, so we can write that down. That's the smaller base, so you can't do anything there. 2 to the 2015 times, and here you got 5 to the 2019. So 5 to the 2019 can be expressed as 5 to the 2015. 5 to the 2015 times 5 to the 4. Why 5 to the 4? Well, 2015 plus 4 is 2019. So what can you do now? See these two? You can group it. So what you'll have over here, you'll have 2 times 5 to the 2015, that law that I was talking about now. And you've got 5 to the 4 there, right? So basically using the same rule over here, which is x times y to the power n is x to the n times y to the n. So here what do you have now? You've got 2 times 5, which is 10 to the 2015 times 5 to the power 4 is going to be, you can put that in a calculator if you don't know it. So 5 to the power 4 equals to 625. So 625. 10 to the 2015 is going to be a number which is basically going to have a lot of zeros. So it's going to have like 2015 zeros after. So it's going to be 1 and 2015 zeros. So you're actually going to have 625 times 0, 0, 0, 0. And this is going to be a lot of zeros there. All right. So therefore, we can now conclude that the sum of the digits will be 6 plus 2 plus 5, which is going to be 6 plus 2 is 8 plus 5 is 13. And that answers our question. All right, from the November 2017 paper, we have the following question here, which says, this is 2.1, 3 to the m plus 4. So here you're going to remove common factor as well. Okay, and I think what we'll do is we'll stop here for this video and we'll look at the 2017 paper 1 in the next video. If you haven't subscribed already, don't forget to subscribe to JL Maths. Also, check out all the videos in order of the work schedule on jlmaths.com. Like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.